In this video, we are going to put a dirty old hoe in the player's hands, and we are going to give him the ability to do attack damage on these enemies and have everything so that Rick can come in and tune the damage. Okay, let's start with a quick and dirty fix to the enemy, which gives them an aim height offset. You may have noticed that our enemies are shooting at our player's feet. It depends on where your root transform is in your player and where that gets picked up as, but we may as well make a corrector. It's a bit of a fudge factor. We can improve this in the future once we get more into our combat, but for now this is absolutely fine. So let's just go for float. I'll serialize it as well, so I'm going to use one of these as a template. And we want it to be about 1 meter higher than it is right now. So we're going to say float vertical aim offset, and we're just going to call it 1 meter as a default. And then in fact, we could actually make it a general aim offset as a vector, and we could make it a vector 3. And then we may as well initialize this to, I don't think we can do this here actually. Let's just see. X is 0, Y is 1, and Z is 0. Let's see if we're allowed to do that. I think you can. Yes, you can. Initialize and use vector 3 up the top there. It depends on some data types you can, and some data types you cannot initialize like that. Vector 3 is a struct, so you're okay. You wouldn't be able to construct a new class up the top here, though. All right, so that's fine. So we have an aim offset. Let's go grab that aim offset, and then down where we calculate the unit vector to the player, we need to think about taking the player's transform position plus the aim offset minus the projectile position. So we're just taking whatever position we have on the player and just adding an offset to it, which means that they now, if we see especially the slow projectiles, if we pause and just take a look, actually we need to do it before the player gets completely pwned by these dudes. So if we pop over here, pause for a minute, and then just take a few frames till one of these guys decides to fire next. No, it's not happening quick enough. I think you can see there, they're all hitting him in the chest. Great. Okay, so that's done. We are now getting the enemies hitting the player in the chest. Right, now we're going to import a dirty old hoe. By the way, this error you get here is because the player is dead. So what's happening is that when we're killing the player, the enemies are going, where's that player gone? So when the player has been killed like that, we really ought to just end the game. I think what I'm going to do is just remove the killing of the player. That's why I didn't want to rush it previously. And the player health will just get to 0, and then we will treat that as the player is dead. We will have to deal with the end game and player dying condition a little bit better later. So Rick will just have to notice when the health bar expires. All right, so we're going to import a dirty old hoe. I'm sorry about the name of the weapon, but that is the humor of our game. If we go to import package, custom package, then we have, well, we've provided you with a download. It's called in weapons.unity package, should be attached to this lecture. You want to just import everything that gets selected here. We've already got a pine tree trunk texture in our case. So it's mainly the hoe itself, the blend file, the prefab, and a couple of materials. So they're going to go into a weapons folder at the top level. That will obviously get a lot more full later. The dirty old hoe folder has within it a prefab and a blend file. Be careful that it's the prefab you pull into the scene, not the blend file, because that will be wrongly rotated, wrongly set up, etc. But there's the hoe sitting there in the scene. And that is it, really. Michael has got all this set up for us properly. It's got some nice materials on it. And there is his initial weapon. So what we need to do next is attach the weapon to the player's hand. So once it's in the scene, the dirty old hoe, what you can do is you can child it to the right part of the player. So you scroll through the player's armature. You go to spine up to, what should we have, right-handed player for the moment? I think so. Up to his right arm, down his right arm, and into his hand is where you're going to drop the dirty old hoe. Then you need to position it a lot better than it is positioned right now. So we want to get it somewhere near his right arm. So if you want, by the way, you can come out of perspective view into isometric view. It can help sometimes, but personally I prefer just to stay in perspective. I'm quite comfortable with that. You just have to get yourself in a position where this is going to work, and then just get your weapon, whatever weapon you decide to use, just get it in the player's hand in such a way that it's vaguely positioned properly, and then preview to see what it looks like. So I'm going to put it intersecting with his hand, something like that. Let's play. As he runs, we should find that the hoe moves, That's actually pretty good. I'm going to roll with that as plenty good enough. We can always rotate and move this around, but we have a hoe in his hand. And you understand that it's moving like that because it's in his hand and his whole body is animated, so it's just hanging off his hand. It makes quite a realistic looking kind of animation there. I like that. All right, so that bit's done. That was very simple, attaching the weapon to the player's hand. Now let's make the player target a single enemy. So the first thing we need to do is that the player itself needs to have the concept of the enemy that it is currently targeting. So let's give ourselves a game object. Current. Now, game object first. If we need it to be an enemy type, we can, but by making it an enemy type, we're making the dependency between the player and the enemy directly. If we make it a game object type, then the dependency is only on the engine, really, and lots of dependencies on the engine are okay. We don't want too many cross dependencies between our own classes if we can help it, to keep things simple. So we can just say current target and keep it as try keeping it as a game object for now. See if we get enough richness from that. And what we are going to need to make the player dependent on is the camera raycaster, because we're going to need to know from the camera raycaster which enemy game object we clicked on. Now remember that the camera raycaster provides us with a delegate here. We can use the observer pattern to say, tell me what you hit. So we need to register for notify mouse click observers. So as a mini challenge, if you want a recap of delegates, go ahead and pause the video and make the player register for the notify click observers event now. Okay, welcome back. So then we're going to need to do a few things. We're going to need to firstly make sure that we have a reference to the camera raycaster. So we're making a dependency there and just call it camera raycaster. Now we need to go find that camera raycaster in start. So I'm going to do that here. Void start and simply say camera raycaster equals find object of type, because there's only one of them in the game, camera raycaster. Okay, so we've got a reference to the camera raycaster. Then what we need to do is register here. So we need to say camera raycaster dot notify mouse click observers plus equals. Remember, we're adding to the list. If we try and say equals, it won't work because we've got an event keyword, remember, over in our camera raycaster, which will protect it. So we can't be overwriting the observers list, but we're just going to say plus equals. Now we need to have a method name. So we're going to say void on enemy clicked. Now we need to match the signature, remember, to the camera raycaster. So we may as well go borrow this stuff. And it's that. And we don't know that it's an enemy clicked at this stage, so we better say on mouse click. Okay. And let me just check that that's a reasonable name. The camera raycaster broadcasts a mouse click observers. Yes, that's right. So on mouse click is the name of the method. And now that we've written the method, we can then register on mouse click like so. Right, it's kind of strange you reference the method as just a name like that, but you can see that they are the same thing. All right, so when the mouse gets clicked, we first just need to say if. Now, the player, again, is going to need the concept of what the enemy layer is. So temporarily, until we improve our layers further, we're just going to expose an integer called enemy layer, making it very explicit that the enemy layer is, well, that the player is dependent on knowing what the enemy layer is, okay? So as long as we know what our dependencies are, and we need to remember what that layer is. I think it was number 9, but we can edit our layers. Enemy is number 9, that's right. And then the player needs to be publicly exposing that. Serialize field int enemy layer equals 9. If we look at a player, why can't we compile? So I've got a problem in one of the scripts. I see. It's just down here. So obviously your things won't expose in the inspector until the scripts are ready to compile. Enemy layer 9, so that's good. Now what we can do is just a quick test here. We can just say if layer hit equals enemy layer to avoid the magic number. And then we can just go ahead and print for the moment. And then we can say clicked enemy. And then we could just put the enemy in, I think. So to get the enemy, we might as well get the enemy. We're going to need the enemy anyway, so let's get it here. Var enemy equals raycast hit. We've done this before, .collider.gameObject. Okay, and what type is this enemy? Well, it's a game object that comes back. So we want to know who the enemy is when we click. All right, cool. So this is a good intermediate test to make sure that we've got a reasonable bit of progress going. Now, I think I've got a compile error. Let's find out over here. Maybe I haven't. No, I haven't. Check the console. We've got these cursor over new layer. That's really distracting. I'm going to delete that message. Clear the console. Okay, so if I click on an enemy, the reference script of the behavior is missing. Object not set to the reference, blah, de, blah. Okay, so what do we have wrong here? Let's just try running again. Okay, clicked enemy 10, yeah? Clicked enemy 9, it just didn't like being recompiled. So that's working. So the player now knows what enemy it is clicking, and it is printing that out. So that's cool. We don't need any longer to print which enemy we're clicking. All we need to do now is to set the current target to that enemy. So current target, which is a game object, equals enemy. And now the player, current target member variable is being set to the enemy. Cool. So we're nearly there, actually. We just need to start dealing some damage. So, of course, that's going to be your challenge. The enemy needs to take damage on each click, and no need to animate the hoe unless you know how. So go ahead, pause the video, and see if you can get the enemy taking damage now. Alrighty then, so welcome back. Now we have this enemy. What we're going to need is the enemy component. It's all very well having the enemy as a game object, but we're going to need the enemy component of it. So we can come in here and say that the enemy component, if we go var, then it'll automatically reduce the type for us. Var enemy component equals enemy.getComponent, and then we can say of type enemy. Now the thing about doing this is that we are still putting a dependency between the player and the enemy, because this isn't going to work. It's not an absolutely required dependency as long as we protect ourselves and say, well, we may or may not have received an enemy component here. But if we go ahead now and assume here that we have an enemy component, we already have the dependency between player and enemy, which is creating more dependencies necessarily than we want. But I'm just starting to introduce you to the architectural concerns here. The game's not big and complicated enough yet to be too worried about this stuff, but it will be soon. And what we want to do is just start thinking ahead a little bit that, okay, I'm still dependent on the enemy here. All right, but it's okay at this stage. So we go and get the enemy component, and then once we've got the enemy component, we're kind of assuming it exists. It does on all enemies, so I think we're okay doing that. Then we need to take damage, and then we need to tell it how much damage to take. Well, that depends on the player, and the player needs to have a float, a serialized float actually. So let's do that here. And it needs to be damage per hit, doesn't it? Something like that, as with 1 click per hit. And the player could do, I don't know, 10 points of damage. Rick can go and sort that out. So you're going to take damage per hit. And that should, I think, be it. Let's see if it works. Now, there's going to be no animation on this hoe, but we can live without that for the moment. It's going to allow Rick to do what he wants. Now, it's fine, but what's happening is that every frame it's doing damage per hit. You see if I hold the mouse down? Every single frame, and furthermore, it is also doing it from any range. So we've got a couple more things to do. We need to make it happen not on every single frame. So we only want this to happen when we first click up. Maybe every so often, but not every single frame that you're holding down click. So how can we do this? We can put a timer in that says, if it's been X amount of time since the last click, then that would actually save our fingers. So why don't we do that? Damage per hit is that, and then we're going to go minimum time between hits. Okay, so float min time between hits, and I'm going to call it, I don't know, half a second again. So it cannot hit more often than every half a second. So then how are we going to keep track of that? Well, we're going to be leaving this on mouse click method, so we know that we're going to need a member variable, a private member variable to float last hit time. And it can equal 0f to give it some initialization. So what we do then is when we actually hit the enemy, we say that the last hit time equals time.time, which we get from the game. That's the game time. And then we've got that, right? So what we need to say is actually you only take damage if time.time minus last hit time is greater than min time between hits. It's a fairly standard pattern here. Then you go ahead and do these two things. Now, please don't forget your curly braces, because I hope you know by now in your coding that this will only execute this statement, not this one. Okay, so you must have your curly braces in your if statements. So it's a fairly simple kind of latching behavior here that makes sure that we only hit as often as we can. Let's see if that's worked, if we got the right semicolons in there. He should only be able to hit twice a second now. Still got a semicolon missing somewhere silly. I think I just didn't save. Okay, so if I hold it down, he's only hitting twice a second. Much better. All right, so the final thing we need to do is think about what the minimum or maximum attack range is. So again, it's another property of the player. And then we just call it max attack range. And I think he should be able to attack about 2 meters out with that long old hoe. So now we have to know something about the distance to the player. So you check that it's the enemy. And then the next thing we need to do is we go and get the enemy. We set the current target to the enemy. That's fine. You can target an enemy even if he's outside of your distance. But we need to now check that that enemy is in range. So we can pseudocode check enemy is in range, somewhere around here. And what do we need to know about in order to do that? Well, we say that, and what we can do is we can just leave if he's not in range. So we can say if enemy.transform.position minus r transform.position is greater than max attack range, and you probably want to put this in brackets like that. Now, just subtracting two vectors like that's not going to cut it. You either need to say dot magnitude, or you could have used the vector3.distance function, but that will do. So if the distance to the enemy is greater than the max attack range, then you could simply return from this method. That's one option here. Now, if you do that, are there any problems further down the method? Well, I don't think so. You're just not going to even try and attack. So I'm happy enough with that we set the target, but we just leave. In fact, we arguably shouldn't even set the current target. So let's just put that code back and only set the current target if it's a valid range. So we get the enemy, we check that it's an enemy layer, we get the enemy from the thing that we've hit, because we have to actually hit something, and then we just check and see if it's in range, and if it's not, we just get out of here. Now let's try that. That should stop us being able to attack enemies that are out of range, and it does with this guy here, and then we get close to him and we can attack him. So now we can only attack guys that are in range, and he's jittering the player, and that actually kind of gives him an attack-like animation. It's actually a bug. It's just to do with the way that where he's being asked to move to, but we can actually move around and just attack players, so the enemies rather. The final thing we need to do then is just make enemies disappear, and the way that we do that is where they take damage. We've done this sort of thing before. We just use the code that we removed from the player, and actually, because I'm using source control, I can go in and look and see what code I did remove from the player. This thing here, if current health points is less than or equal to 0, destroy game object, and that's a very quick way of me putting that back in for the enemy. Shouldn't cause so many problems with the enemy, because once the enemy's gone, there'll be nothing to click on. So we shouldn't get the same bugs we do with the player. So this guy, I can just kind of stand there, do crazy things with the hoe, and he disappears, and he disappears. But unfortunately, my player is already dead. So I think that's going to be fine for now. It's going to give Rick everything he needs in order to be able to tune up the enemy's health level. Let me just check we've got all the obvious things. So the enemy has a max health points on him. So if I turn that up, then, well, you need to turn it up in play mode, out of play mode. So if I make that 800 health points and we start the game, is he starting with 800? No. So this would be a useful thing to sort out. The player is not starting with his max health points. So where are we assuming that he has 100 health points? It's here. Current health points equals 100F. So instead of hard coding that to 100F, we make the on start current health points equals max health points. And then what that does is it means that if Rick comes in and goes to the player and sets the maximum health points up, that it still represents 100% health. It's just you'll be able to see from how he's being hit that he's more dangerous, he's more, solid. And then what do we do on the enemies? Same sort of thing. We need to make sure that their max health points, if we turn that up on this chap here to say 134, his health bar should also be full. It's not for exactly the same reason. So you just go to the enemy and you look up here and you say it's exactly the same things we just did on the player. Current health points equals 100. Instead of initializing it there, you don't bother, or you could set it to 0 if you wanted to. But what you want to do is in start, you want to go current health points equals max health points. Okay, you don't have to set floats to 0 at start because that's what they're going to get anyway. All right, that's cool. So now the enemies, like this dude here, he can be made super strong. He can have 300 health points. And when we go ahead and click on him, then you can see he's a lot more powerful. We could, of course, go to our player briefly, even at playtime, and we could turn up his damage per hit to 100. Now when we hit this guy, we're doing a load of damage. In fact, we're super dangerous now. All right, so I think Rick has got all the levers he needs to pull in order to tweak up this game. So I'm just going to quickly check that this actually indeed works over in Rick's village. I can't imagine any reason it wouldn't, but this just checks that we've applied back to the prefabs appropriately. So we're being shot at, we're hitting him, he's hitting us. I think it all looks good. So I will look forward to seeing you when I come back and do my next set of videos.